Okay, we'll come back again. Now we have 8.3. It's talking to about trigonometric integrals. Before you are studying this section, it's better to review 8.1 and look at the trigonometric identities and trigonometric integrals in your mind. It should be in your mind because you don't know why we do like that. So we have a direct one and indirect one. Now we have what? We have integrals. You can see from here. He told you that's a direct, but what we have something like that. And here we have 3 cases. When you say trigonometric functions, we mean we have many things. For example, if I have sine of x multiplied by cosine of x with different exponents. So how we solve that one? So you make it 3 cases. If one of them odd, if the one of them odd, I don't know, you call here how, and m odd, n odd, okay, or m odd, m and n both are even. So how we deal with that one? These 2 cases have the same idea. That one has different idea. So means that instead of you say I have 3 cases, it's better to say I have 2 cases. Why? Because one of them odd, we are going to solve by that. One of them is not odd, both even. How we solve them? Before I am going to give you how to solve that one, if I have simple example, sine of x and cosine of x dx. So how we solve that? Yalla. Hello. Easy. We solved that many times in Cal 1 in. Thank you. Exactly. We have box, d box. This is box in my mind. We see derivative of sine, cosine. So here's power 1. So I say box, d box, right? B, db. So I will say sine square of x over 2 plus c. And this is the first. The second note, if it's not inverse, if the function is not inverse, we can play with the exponent. What do you mean by that? For example, if I have sine square of x, I can write down like that. Sine of x square. But careful, that is not equal to sine of x square. We don't say that. So if square on the n, we mean on the function. Means that we have sine multiplication. Understood? That's why if I have such example like that, I say derivative is equal to what? Minus cosine. Thank you. The same. Make the box. Use that one. Now box, d box. So I say is equal to what? Sine cube over 3 plus c. Understood? So think about this example again. What we have? If one of them odd, the other, if it's odd or even, we don't care, right? We make a decision. Why? So that's why I say case number 1 and 2 both are the same idea. So if n is odd or m is odd, the important thing you have one odd. The important thing we have one odd. The important thing we make something and the difference exists. For example, if I have cosine to power 3x sine x dx. Now, in your mind, I say I have a sine, cosine. One of them odd, the other also odd. So I'll make that one as a box, right? So derivative of box equal to minus sine. Now I have box, d box, right? So I say is equal to. Did you understand what did I do? Easy? Hello? Do you have any comment? No. Good. So how we solve that one? In any case, if I have any power and again any power of x, if one of them odd, up to you. That one does not make a sense, does not make a change. I'll separate one of them. For example, let that one be odd, be 5. I see that one is any number. Let that one be any number. And that one is 5. I see it's 4 cosine x dx. I will make that one as a d box. Understood? So I make that one of them to be out with my d. Understood? Or if that one is odd, for example 5, and cosine is any power, 2, 5, any power, I don't care about that one. So I'll bring one of them to here. I make a d box, d what I need. Then it remains 4 with any exponent. This is the first step. The second step is what? To change all here opposite to cosine to here. So I'm going to change that one to sine. How? By identity. Because I have sine, I'm going to change all things here to cosine, opposite, okay? How? By identity. To get more information, I'm going to solve that example for you. Sine to power 3 dx, sorry. Cosine plus what? 2, right? Square. So as I told you, which one is odd? So I have one sine here. Understood? What did I do? Dears, did you get the idea? This is the first step. So I will get sine square, cosine square, and here we are. I make it to the other side. I give a space to be in your mind. What shall we do? You got it? This is the first step. The second step, I say what? Change all things opposite to that one, right? So here should all of them be what? Cosine. So that one is cosine. Okay. Let me make a box again. Okay. So this is cosine by itself. So how I change that one to cosine? Am I right? I change sine square to 1 minus cosine square. How? Which identity? Plus cosine square is equal to 1. The first one that you got in the trigonometry course in high school. So by sine square cosine square equal to 1. Now, here we are. Everything changed, right? Am I right? Do you have any question? What's up happen? We multiply that to here. So now everything is ready. How? Separate them. You have a subtraction. So everything is ready here. Why? Why is it easy we solve it? Why?
Because the sign is odd.
Yes, and box, d box, thank you. Derivative of cosine. Derivative of cosine. So I will get minus cosine to power 3x over 3 plus cosine to power what? Over 5 plus. You got it? So in case we have sine cosine, one of them is odd, I'll try to make one of them, one of the power, linear one, in the box outside. And here I am going to change all of them opposite to sine, or if I have a cosine, I'm going to all of them make that sine by this property. This is. Then later I am going to separate them and I will get something like that. Box, d box. Easy? You got the idea, dears? Question? No. How about if I have cosine to power 5 alone? I have cosine to power 5 alone dx. So how we solve that one? You should ask yourself, in the table 8.1, I have cosine of x dx is equal to sine x plus c. Am I right? And we learned about how to solve that one. Do you remember how we solved that one before? How we did that? We changed to do you remember? Now I'm asking myself, if I have 3, how I solve them? If I have 4, 5, that's how to study. So if you know how to solve 3, of course you know how to solve 5. Because the same idea, odd, odd, alone, alone. Okay, today I say if you have sine, cosine, but where's sine? Where's sine? I'm going to solve that one for you before the example. I'm going to solve that one for you. Where is sine? You can imagine in your mind, sine is 0, right? Sine to power 0, 1. So I have an odd and something. So that's why I am going to use the same method. So how we solve the odd? We say that, how we solve the odd? Yes? 1 cosine, yes. Bring 1 out. Here's cosine. It remains? Okay. What was the second method? The second step? Cosine squared to what? 1 minus sine. Thank you. Next step. right? Derivative integral of cosine. Derivative of the second integral. Box d box, I told you, right? Yes. What's the negative sign? No, integral of sine is negative cosine. Because the derivative of here is equal to there, that's why. Understood? How about 5? I'm not going to solve the 5. 5, you will make it 4 by 1, right? 4 by 1. Now, we change that, he wrote like that. You can say sine of x dx as a box. So, he make it like that for you to outside. So how we change 4? I don't have this property like that. I have the property like that. Cosine to power 4x plus sine to power 4 of x equal to 1. We don't have something like that. Careful. We just have it for squared. So I'm going to change to power 4 to what? To power 2, 2. Then I can change that onto 2. That's why we have here. Then how we open that one? You see first square. Let me solve it for you. Cosine to power 5x dx. We see equal to cosine to power 4 cosine dx. Here we should change to what? 2 by 2. So 1 sine square cosine x dx. Now, yes. So how we open the complete square, or how we open the square of the bracket? First square minus 2 multiply first second plus second square. Am I right? Then what was the next step? What shall we do? Hello? Same step. Multiply to the bracket. So I'll get what? Cosine x dx sine square x cosine x dx sine to power 4 cosine x dx. So that one, how about that one? Integral of the second, 10 times we did like that. Is equal to? How about the other one? You got it? Box d box, again, box d box. So here we are, we have that one. Yes? Mhm. No, I didn't bring it out from the integral. Well, okay, separate under this integral. Never would do integral. Yes, the same. يقل هم نبت الدبل عندنا كله. أقرأ شوار ويقوى. Oh yes, you are right. كفرهم. Otherwise, no, it is the same one integral. Just I separate inside. For inside, it's okay. Yeah, you can do. It's a property. Look. Okay. Now, how about if I have even with even? For example, this even and even means that n and m be even. What do you mean by that? For example, I have sine square of x. I mean, a little bit harder. I'm going to solve that one for you. Sine square, cosine square of x dx. How we solve them? In that case, you are going to use this property, the properties. Both of them. We need both of them. Understood? So here we are. I'm going to change that one. I say I, so I equal to. I'm going to change that one, multiply to that one. Dx. 1 minus cosine 2x 2, 1 plus cosine 2x over 2. 1 over 2 multiply 1 over 2. Hello? 1 over 2 multiply 1 over 2. MashaAllah. 1 over 4. Well done. And remains 1 minus cosine 2x multiply 1 plus cosine 2x dx. So how's the result of that one? Exactly. If I have a plus b multiplied by a minus b, I'll get a minus b squared squared. You know about that one. So the same thing I have here. I have what? I have 1 over 4 outside. I will get 1 minus cosine 2x squared dx. Am I right? So the integral can be distributed over subtraction. So I'll get dx and I will get dx. Okay. So I'll get 1 over 4x. How about the other part? How I solve that one? If it's square, how we solve it? No, we don't have sine here. If I have sine here, you are right. So we don't have d box. Half angle. Right. How you solve that one? You don't know because I didn't say many times. Maybe I say 9 times. I didn't say that one 10 times. That's why you don't know. I mentioned just right now. Huh? How you solve even? Look. How many times you mentioned that one? Look. If the even alone, how you solve it? Even in Cal 1, we mentioned that one. So we are going to use half angle idea. How? I'm going to say plus 2 cosine of what? 4x. Thank you. Because we have 2. 2 by 2 is 4. So we'll get 4x. So that's why we say 1 over 4x minus 1 over 4, 1 over 8. Again, integral of 1 plus cosine 4x dx. And the result will be 1 over 4x minus 1 over 8 x plus, sorry, minus 1 over 8 cosine 2x and that one is easy, is equal to integral of cosine is equal to sine 4x over 4 plus. This is the simplest one. And in your book, there's a little bit harder because that one is square. So I'm going to change that one to here. Change that one to here. It's easy. But for that, I'm going to make it to 2 by 2. The square will change to here like that. Then all these will come out, the numbers, it remains like that. Why? Because first square, 1 by 2 first by second, plus second square. Here you are. Then you multiply that one by here, that one by here, and we get this all together. Look, to get that, you understand or not? You should solve all these you should know how to solve that one. That one is equal to x, that one will be sine over 2, that one is square, I'm going to change it again. The square, I'm going to change it again. And I have a odd, how we solve odd. I'm making one odd out, the second like that, and go on. So this is like a revision for you. Then you'll get that result. For here, I am stopping because I think you are stuck with me. So